Lab number 2, projectile motion. The experiment part of this experiment goes pretty quickly. You'll be a while doing the analysis afterward. What this is it's a two-dimensional version of the experiment we did last week. You had the falling, it was the free fall lab a week ago. You had the falling object, and as it fell, we used the electric sparks and the heat-sensitive paper to mark where it was at regular time intervals. Well, we want to be able to do the same thing with an object that's moving in 2 dimensions rather than in, just along a straight line. So a lot of the analysis is the same sort of thing over again, but the apparatus this time is over here on the next table. Get you a little closer to that. So our projectile is going to be this little steel marble, little ball bearing. And all I do is I just roll it down this ramp. When it flies off the end, it becomes a projectile for a short time, flies through the air. And then I've got a cardboard box over there to catch it so that I don't have to chase it across the floor in the dark. So that sort of thing. To record its position at regular time intervals, the thing that's going to play the role of the spark timer in last week's lab, we have, well, 2 things that are going to work together. There we go. Got a camera. Yeah, I know it's kind of an antique. Just between you and me, I don't actually have any film in it. I used to actually run through the process of creating a photograph for the class, and then eventually I figured out that if I just whipped out an old photograph afterwards, as far as what they saw, it looked exactly the same. I'm not sure you can even get film for this anymore. But anyhow, this has been set up so that when you probably heard that click, that's the shutter opening. And it's still open. It stays open until I take my finger off it again, okay? This other unit over here is a strobe light. So what I'm going to do in a few minutes here is I'm going to turn out the lights in the room. We'll turn on the strobe light. I'm not sure how that's going to come out in a movie because a video camera has a strobe effect of its own. It takes a certain amount of, I don't know if it's like 18 frames per second or 22 frames per second. I'd have to look it up. I don't remember exactly. But we'll see how that meshes with the strobe light flashing around 40 flashes per second. But, well, anyhow, we'll do what we can. So we turn out the lights in the room. I release the ball. As it flies through the air, every time, see, I open up the camera before I release the ball. So the whole time the ball is in the air, light is falling onto the same piece of film. Okay, it takes just one photograph, a multiple exposure photograph. Or you could do this with a modern digital camera also. It doesn't make any difference whether it's film or the electronic sensors they use now. But as the ball flies through the air, every time the strobe light flashes on it, it makes another image on the same picture. So you get a series of dots on the photograph, a 2-dimensional version of the series of dots that went down the spark tape on last week's lab. I've put a grid of 1 centimeter squares in the background. I don't know how well you can see them from the, yeah, I guess that shows up pretty well. So all of those dots are in front of that 1 centimeter grid. And that's it. Well, you sit there, you look at the photograph, you look at the horizontal and vertical position of each of the dots, each of the images of the ball, and you record them in a table, and then do some calculations that are kind of similar to last week's lab, except now you do them once for the X components and again for the Y components. This is the actual apparatus that's in the picture now that you'll be working with. As far as the photograph, rather than this cheap little Polaroid camera here, when I first did this experiment quite a few years ago, I had the guy who was teaching photography at the time help me, and he got one of the large format cameras out of the photography lab, you know, the ones where you put the piece of black cloth over your head and all of that cool stuff. Takes a piece of film that's about, you know, that big, and that gives you a better picture. Plus we tried about 6 or 8 different shots before we got one that looked good. But so it's not the same camera, but this over here is the actual apparatus that you're looking at a photograph of. Now, the people who are doing it live here, the face-to-face people, I don't know if I can get by this card. Okay, I'm back. This little camera here produces a picture that looks like this. This one was actually produced by the camera that's right there on the tripod. But we've got these nice 8x10s from the camera from the photography lab that I was talking about. But for those of you who are working from home, rather than trying to look at this 8x10 and yeah, what's going to come out a little clearer is that has been scanned, okay? And it should be sitting right next to where you clicked to get to this video. There should be something right next to it that says the photo for lab number 2. And if you click on that, there should be, like I said, a scanned version of the photograph. So this video is to show you where the photograph comes from, and right next to it is a JPEG image of the photograph that you can actually look at to collect your data, and then you follow the directions and do the calculations. Okay, so I think that's pretty much the explanation of how it all works. Let's, maybe I'll get you a little bit closer here. Yeah, that's about as close as I can get you. I'm on the end of the power cord on this camera. Yeah, that might be a good spot there. You can see the camera on the one side, you can see the, okay, here we go. Strobe light. And yeah, the way I've got this, I'm going to be right in front of the camera. Actually, I guess I'm not in front of the camera. It'll be all right. Okay. Open the shutter, release the ball. Close it. Turn this off. And the way this instant film used to work is you'd pull this out of the side of the camera right there. You waited 20 or 30 seconds and peeled some stuff off. and then there was the photograph. And so what you need to do is for the X components, let's see if I can get this so it shows up on here. You have to, I don't know if this is showing up where you are, but there's a dot there, there's a dot there, there's a dot there, there's a dot there. So for the X column, in each case, it's how many squares up from, probably you put the origin at the bottom somewhere. You'll have to estimate a fraction of a centimeter, like that one there might, looks like it's a little more than halfway from one line to the other, so probably 6/10. You do that for each dot, and or actually that'd be the Y's. Vertically, that's where you fill in the Y column. And similarly, how far horizontally from some reference point, that's how you fill in the X column. And then once you do that, delta X over delta T to get the X velocity, delta Y over delta T to get the Y velocity, and so on. Just follow along through the directions. And that's probably everything. Contact me if you have any questions.